Wait, so for this one right here, Pythagoras theorem, what we're looking at is another demonstration of what it actually is. We have a right angle triangle here, and if you look at the side A, off of side A they made a square, and of course they made little squares. And so this has 1, 2, 3 times 3. How many little squares are there in there in a 3 by 3 square? Well, let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's because 3 squared equals 9. Okay. So there's 9 units squared inside there. The B square is 4 by 4. 1, 2, 3, 4. So 4 squares is the length of B, and so it's a 4 by 4 square. How much area do you think there is? How many squares? Well, let's count. We're at 8, 9, 10, 11, 12, 13, 14, 15, 16. And that makes sense because 4 squared equals 16. So they actually have little squares. It's 4 square units. Okay? Or 4 squared, which is 16 square units. And the C side, 1, 2, 3, 4, 5 squares. So its area is 5 by 5. And if you count the squares, Nevaeh, is it really that important? Works better to pay attention. 6, 7, 8, 9, 10, 11, 12. I hope you're writing this down. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25 squares. 5 squared equals 25. Okay. So we can physically count the area. Now, to use our formula, we're going to show you how to use your formula to find each one. So let's start with C squared. We start by writing down C squared equals A squared plus B squared. So we write out our formula. Then we substitute in. So A is 3, B is 4, so that becomes 3 squared plus 4 squared. And then when you're showing your work, you want to find your answer to your squares. So 3 squared is 9, 4 squared is 16. Then when you're showing your work, Lenny, you writing this down? It's an example of how to do it. It would be helpful to have this. C squared equals 9 plus 16, which is 25. Now we have to undo the square root. So we get C equals square root 25, which equals 5. So that's how we show our work for C when we're finding C. To find A squared, we do something similar. But because it's a leg, you can't make anything longer than the leg. So we don't add, we have to subtract from the hypotenuse. So A squared equals C squared minus B squared. And then we substitute in. A squared equals 5 squared minus 4 squared. Then we find our squares. So 5 times 5, that's what 5 squared is. 5 times 5 minus 4 times 4, which is 16. Then you do your subtraction. 25 minus 16 is 9. Oops, not 9. That's 9. And how do we undo the square? What do we have to do to both sides to undo the square? You have to do the square root. So we get A equals square root 9, which equals 3. Now, I already told you in regular Math 10, that's your answer. It's called a radical. But for us, let's go and round to 1 or 2 decimals. And that's fine. Okay. So if I was going to find B, it'd be very similar. Right? I could still use the same formula, but it'll be B squared first. Now, I'm not finding my hypotenuse, so I don't want to add to make something longer than the longest side. So instead of making things longer, I want to subtract, make them smaller. Okay? So b squared equals c squared minus a squared. We substitute in 5 squared minus 3 squared. We find the answer to the squares, which is 25 minus 9. We do our subtraction. B squared equals 16. How do we undo the square? What's the opposite? Square root. So technically, we square root both sides. Now, if you don't write the red part, that's okay, right? That's fine. That's like a higher level math. For us, we don't need to do that. You just got to write the blue. Okay, b squared equals 16, and this one equals 4. It's kind of rare, actually, that we get whole numbers. This one's really cooked up. It's more typical to get decimals. Questions, comments, or concerns? Okay. So, again, here, the first one you use when you find the hypotenuse, and then you use it because you're adding to make the hypotenuse the longest side. Okay, that's why we use the very first formula. If you're finding anything else, you can use either of them, right? For a leg, the other two sides, either use a squared or b squared, whichever one you like, it doesn't matter. Okay? You have to make sure, though, that c squared is your hypotenuse. That c squared, or c rather, is the longest side. That's the most important part. At the end, you should always check, is C the longest side? Because if it's not, you should change your addition to a subtraction or vice versa. Okay. Now, I'll be honest, Mr. Barker never uses the bottom one. I always just use this one because it doesn't really matter which one's A or B, right? A and B can switch. It does not matter which is which. Ooh, that rhymes. Oh, yeah. I know. Here we go. I did. Hey, Oscar. Come on in. Yeah, absolutely. Well, you saw my performance last night. You might see that I'm a professional drum player, but so be it. Some of you guys obviously missed out. All right. Okay. Any questions? So on your calculator, I want to make sure you can do this on your calculator because that's the biggest thing. If you can't do this on your calculator, you're messed up. So let's practice this right now. All right. If you are trying to find this on a squared equals square root 9. So you can either type in 9 square root button or square root 9 equals. Okay. Most phones, I say 99% of them, you're going to have to type it in backwards and do it this way. Most calculators, I mean, we'll say 99% of them, the new ones, you enter it in this way. So take out your phones, take out your calculators right now, and let's practice. I want to make sure that you can do this and get 3 as your answer. So on my calculator, eyes up here, I press this button, 9 first, and then I press my square root button. Not a lot of phones have that 2 there, but a few of them do now. And I go right to my answer. If I was going to use my graphing calculator, see if I can pull that up. How would I do that? Graphing calculator, that would be under TI. Oh boy, TI. No. I'll see if I can find it because I don't have it set up since I switched computers twice. Oh, here we go. Nope. Calculator.rom. Here we go. Yes. Sweet. Okay, so on my graphing calculator, here's my square root button right here in yellow writing. So in order to get the yellow writing, I have to press the yellow button. And now the square root sign appears. Then I'll press 9, and you should have a closing bracket. Okay, then I press enter, I get 3 as my answer. So if you actually see that little symbol on your screen like this, if you see that symbol on your screen, you have to enter this button first and then 9. That's how you know. Most phones are not like this. Only a few like the brand new Androids are. Okay. Okay. Ever practice that now? Anyone not get 3 as your answer? Come up right now. Go. Practice it. Do it. Do it. Do it. Do it. Do it. No, if you'll know if you don't get it. Come on up real quick. Grab one. Anyone not get it? Again, there's some weird calculators out there. You may have trouble finding the button or something. Yeah. Yeah, so there's another one that you can, that's sometimes there. It's like a x to the y. It kind of looks like this. Okay. With this one, you'd have to press 2, then this button, then 9, then equals. Because the 2 is, yeah, exactly. Yeah. Okay. Anyone not able to use their calculator? Wait, let's do a little bit of practice then. Let me get rid of this so it doesn't mess my program up. Okay. So we're going to check real quick. Erase. Let's use a nice little example here. Okay. Here we go. Wait, draw this triangle. Okay, 10, 15, and we want to know this unknown side right there. Okay, draw this triangle. So the first thing you do after you draw it is you got to figure out, you should have room on top of the next page, right above example 2. Okay. So the first thing we're going to do is label our hypotenuse. How do we find our hypotenuse again? We start by putting our pencil on 90 degrees and then drawing what? An arrow. The 90-degree symbol is like the head of an arrow pointing at 90 degrees. Sorry, at the opposite side. So then we label this the hypotenuse. Now, are we trying to find the hypotenuse, or do we have the hypotenuse? We're trying to find it. So we start with c squared equals, and because we're trying to find the longest side, we should add our squares. So 10 squared plus 15 squared. That will give us the longest side adding. That's why we're adding, because we're trying to find the longest side. So we then go and find our answer by finding our squares. 10 squared is not 10 times 2, it's 10 times 10. What's that answer? Plus 15 squared, which is not 15 times 2, it's 15 times 15. So for me, I got to use my calculator for that, which I could if I could find it on my thing. Here we go. 15 times 15, 225. Okay. So then I will go and add that together. 100 plus 225 is 325. Now I have to undo my square by square rooting. So c equals square root 325. Go to your calculator. Tell me, make sure the roof covers all the digits. Okay, use your calculator. What do you get? So on my old calculator, I have to go 325 first. Then I press the button. 18.02. There you go. Don't worry about the rounding. I won't be marking that. Any questions on this one? Yeah, 1 or 2 is fine. Like, because this one, it was 18.0 and then behind it was a 2, I probably just left it as 18.0. Yeah. I won't be marking it for you guys. Now, in a couple classes, it makes more of a difference, and we'll talk about that, but usually 1 decimal for sides. Any questions? Anyone not able to use their calculator? Jen, you guys good with that calculator? Or need help? Oh, come on up. Let's have a quick look. Wait, next example then. Copy out this triangle, 20, 15, and we're trying to find that unknown side right there. There should be enough room at the top of that page to do it. Okay, so first of all, we label what? The hypotenuse. Which one is the hypotenuse? Well, 90 degrees points at it, so this is your hypotenuse here, 20. Now, since we have the longest side, should we add to make something longer than the longest side? No, we don't want to add to make something longer. We want to subtract. So we're going to use the subtraction formula. Okay, a squared equals c squared minus b squared. Some people should be comfortable now to start with the second line, 20 squared minus 15 squared. Okay, and so then you go and find the value. 20 squared is not 20 times 2, it is 20 times 20. What's the answer for 20 times 20? 400. Okay. 15 squared is 15 times 15, and you can use your calculator, 225. Okay. Then we actually do the subtraction. For me, I'm using my calculator because it's a slow Friday. So 400 minus 225, 175. What's the next line of work? Square root. Okay, so we have to get rid of the square by square rooting 175. Now go to your calculator, make sure you try it, get an answer. Okay, get an answer. On the old school calculators, you go 175 square root, 13.2. If on the new calculator, and that's what your phones, that's what you'd use for your phones as well. And then for the newer calculators, where you actually have that symbol, you press second function, square root, once you turn this on. Okay. So square root symbol's in there, then you go 175. I should use a bracket to close it, although for simple stuff it doesn't matter. Then you get 13.2 as well. Okay. All right. Any questions? Good. So you can see here's some more examples doing exactly similar stuff. The only thing that makes it a little bit harder is if you have more decimals. Now, one thing you want to do is you want to keep all your decimals if possible. So if you're looking at this question, I didn't round it. I kept all my decimals. I kept all my decimals. In fact, when I do it on my calculator, I keep everything. I don't round it. Okay? You'd only round here the final answer. So you only round the final answer. Now, I'll be honest. I'm not going to lie to you. If I had some number like 10.263458917, if I don't know how to use my memory buttons on my calculator, I don't know how to keep all those decimals, how many decimals do you think I need to be accurate? 2, 3, yeah. 4 for sure. If you keep 4 decimals, you'll be accurate for sure. So if you're doing math and there's a ton of decimals, you don't know how to keep all the numbers on your calculator, you're unsure of BEDMAS, you don't know how to use the memory button on your calculator, then use 4 decimals and you'll be fine. 4 decimals will always be accurate for trigonometry. Okay, always. Okay. Any questions? All right. So some of them, like these ones here we did yesterday, we're just using the letters. Then here it's already set up for you. You're just practicing using your calculators. Okay, and then here now you're doing Pythagoras yourself for number 3, 4, and so on. Okay, and then we have some word problems. For your word problems, you will always have the diagram given to you. Okay, so you don't have to draw the diagram from scratch. All right. There you go. Let's just do up to question 6. Okay, up to question 6. Because some people need to catch up on other work. Okay. All right. Good. Pitter patter. Get at her.